Okay, good afternoon. My name is Mary Jo Black, and I'm here from the Forsyth County Geographic Services Department, where I'm a GIS specialist. And I'm here today with my colleague, Jerry Oberholzer, and he's with our planning department, where he uses GIS daily. And so what I want to do today is introduce you to GIS, explain what it is, explain how we use it here at the county, and then I'm going to turn it over to Jerry to talk about some of the specific ways his department uses GIS. Your teacher asked me to tell you a little bit about how I got started into GIS. And this is one of the guys who helped me get started. This is my boss, John Kilgore. He is the director of the GIS Services Department in Forsyth County.
Hi.
And he's going to be here today to answer some questions at the end and help us sum everything up. And I was going to say, I actually started out 100 years ago as a park ranger. I loved natural resources, biology. And while I enjoyed that, I thought there was probably something I wanted to do differently or more, and I enjoyed computers too. And so I started looking at how I could help the natural resources, how I could best save them. And one of the ways I saw people doing it was using this new thing called GIS, where they could map out greenways and trails, where they were saving areas of land that were specifically purposed for endangered animals, like snowy owls or the Florida panther where I was down in South Florida. So I realized that was a really powerful tool. Plus, for me, it was fun because it's this kind of analysis. It's like doing puzzles almost every day. You're trying to figure out how to answer questions and do it and with a methodology that can be repeated. So that's what drew me into it, and that's what got me a job in geography and GIS, which I enjoy very much. When we're talking about GIS, the important thing to do is to think about geography. There's no GIS without geography. It's based on asking questions and then modeling those answers that you get back. And we do that usually through a vehicle of maps. That's one of the ways. And if you think about GIS and geography, you have to think about cartography and look at the first maps, which are as ancient as we are. You know, written up on the cave walls. They've been there forever. I love this one. This is an example. This is Babylon. Tigris and Euphrates rivers running through it, and these small circles are the other kingdoms, and the circle around it is the sea. And that was their world. You know, that was the map of the earth for them. And it looks a little funny to you and I now, but struggling to display what we care about, in this case, where they lived, their world, that's the same problems we still have today in geography and in GIS, because maps are a lie. All right, my boss is going to think that was dramatic, but if you look at it, the Earth, and Jerry's head, is round. The maps are flat. So anything that you're modeling off the real Earth onto a flat map is going to be possibly altered or distorted. And just in your head, take a peeky at Africa and take a peeky at Greenland. When we talk about this, we talk about projections. Projections are an important part of geography and GIS because they help you display your data in a meaningful way. For example, if I'm thinking about Greenland, Greenland's about 840,000 square miles. Africa, 11,800,000 square miles, over 14 times larger, and yet in that projection it looks not that much bigger, right? Yeah, so this projection works probably for sailing and navigation, but if you're really trying to look at the world and how it's fitting together and relative sizes, you're going to want to choose something else that will show you that. And obviously, on a global scale, this is very important, but even down to a county scale, we want to be careful what we pick and choose and how we show that through our data. And geography, cartography, projections, these are all part of spatial data. Spatial data is going to help you locate, figure out how many, what kinds of things you have. It's going to help you determine what kind of scale you're going to present it at. And if you think about it, I mean, look around the room. What here almost does not have a geographic component, like your desk? Well, that's here now, but it was probably made someplace else, right? So that's two geographic components right there. You know, our clothes, you know, this building, your next classroom, there's a map to that. There's geography to life. And why does geography and all the spatial data matter? because it helps reveal patterns. This is one of the classic examples. It's one of the first ones you cut your teeth on that got me into GIS. Is looking at, jumping back in the way back machine, we're going to London, 1854, the Great Cholera Plague in Soho. Now at the time, people were dying, hundreds and hundreds of people were dying every day. It was horrible. And there were two theories. The first and most popular one was right over there, that big green box. That was an old cemetery where they had buried bubonic plague victims about 100 years previously. The black dots were the drinking water wells for the area. Most of the people thought that the cemetery was releasing vapors that were making them sick. But a Dr. John Snow, he was kind of smart, and he realized pretty much if you're going to poison an entire population, one of the easiest ways to do it is through the water supply. So he was very concerned about the wells and kept trying to talk about them, but couldn't get a lot of attention because of the vapors. So he went and mapped each one of the cholera victims' locations and then determined which well they were drinking from. And by doing this, what he determined was this Broad Street well was the source of the cholera outbreak. It was true. What happens is these were shallower wells. They were only about 22 feet down, and so they were getting inundated with sewage and things like that, so they were being poisoned. Whereas some of the deeper wells, they had more topsoil between them. They didn't get as much contamination. So he was able to prove through this geographic analysis the Broad Street well was a problem, closed it down. He saved thousands of lives by doing that. Geographic information systems, that was an example of one without a computer. What we say today now is, in general terms, geographic information systems is any information system which allows you to integrate, store, edit, analyze, share, display any type of geographic data. And if you think about it, Dr. Snow, he had the graveyard and he had the wells. But what if there had been more components? What if he needed to see where you worked, where you lived, where you went to school? He needed to know where you bought your meat and where you bought your vegetables. When you start getting a complex analysis like that, it would have taken him a long, long time. So now we can do that kind of stuff in hours, using computer systems. With GIS, there are 5 main components, and this will be on the test. The 5 main components of any GIS are hardware, software, data, methods, and people. And what's going to happen is everybody looks up here, especially my boss when I ask them for new computers, and they get all caught up with the hardware and software. But I'm here to tell you that any successful geographic analysis is based on the very best data you can acquire, a very solid scientific methodology, and people who will follow through with it. So all 5 components are obviously very important. The better hardware you have, the faster you can run these things, the more lives you could save. For example, the CDC, based right here in Atlanta, you might have relatives who work there. They do stuff like Dr. John Snow all the time, avian flu, swine flu. They do analysis like that. I have many friends in the GIS world who work for them. With a GIS, you're going to look for visualization, database management, and spatial analysis. To do that at the county, we put together all of these layers into one place. So I would get land use from Jerry, streets from the engineering department, districts from the commissioners, parcels from the tax assessor's department, put it all together so that I can show people where things are in relation to other things, where things have been, maybe how things have moved and changed, like population. And the reason I get to do this all day for fun and really enjoy my job is because what do you get looking at this? A headache. That's what everybody gets. These data tables, each one of these rows, it's a feature. It's one of those cholera victims, or it's a person and their income. It's some bit of data, but it's very hard to understand it until somebody puts it on a map. So what you're seeing here are the 2010 census data information for people over 50 years old who live here in Forsyth County. So you can see from 2000 to 2010, the lighter colors to the darker being the most, we've had some population growth in our over 50 population. Now that's interesting enough, we're seeing something, but now if I put it together and show you where these big areas of senior population boom are happening, now you can see we've had a big boom up here, but even, actually most of the county has experienced a boom. And down here in the south, they're at 11,000. Everybody else is kind of at around 5,000, but they have 11,000, over here 7,000. So we've had a giant senior increase in those two areas. Now our Senior Center Services Department, what they're doing right now is looking at what we currently have. These are our 3 service areas. These are a 5 mile, the dark parts, radius of their service area. And the lighter colors are the 5 to 10 mile service areas. So what they're seeing already with the new 2010 census data is that they probably don't have enough coverage down in the south part of the county. They've got more seniors there and up here on the west side. So they're looking to look at their long-range plan, short-term plan, and modify what they do to better serve the county, because now they can see that data in a meaningful way. Also on the quiz, there are 2 types of ways to work in the GIS world. You've got raster and you've got vector. And raster data is probably what you're familiar with because we all have our phones, we're taking pictures, it's picture data, it's pixels in those pictures. Other types of raster data might be topography, slope, and temperature. Most of the maps you see looking around are often vector, which are points, lines, and polygons. So we use those 2 different types of data to work in GIS, raster and vector. I'm going to give you an example. This is a spatial analysis for fire station number 3 that we did. You can see this is the fire station number 3, and this is everybody within a 5 mile radius that's being served. What happened was a bigger, better space became available, and if they could move that fire station just 1.5 miles down the road, they could get a better engine for the area, they could update the living area, you know, it would be a better service vehicle for the fire department. So they wanted to know what would happen if we moved this fire station 1.5 miles, which doesn't seem like very far, but when you start moving things around, things change. The pink center in the middle, that is people who remained unaffected by that 1.5 mile move. Everybody in the dark coral is now left out of a 5 mile route from that fire station number 3. The light pink over here on the top are the new people who were added to this service area. So if we look at it from this point of view, what we see is that we've lost coverage. You can see we put the building footprints on here, added building footprints. Over 2,000 buildings and 5,500 people lost coverage, but we only added 2,000 people. However, if we add on top of this other fire stations within 5 miles, so, you know, fire station number 7 and 12, they're covering within 5 miles all these areas. So we only are left with one area that will lose its 5 mile service limit. 26 buildings, 76 people, so probably commercial, not commercial up there. And in our area of new coverage, suddenly we're serving 2,000 people more. And if you think they've got a better truck, they've got better service calls, so they decided with this data that they were really serving the citizens of Forsyth better by moving that facility. So they used GIS to do an analysis and look at numbers and make a decision. The goal of GIS in the county, it's always for me to provide data to people who are trying to make decisions. And these are big scale decisions. Do you move a fire department? That's life or death. You know, some of the things are not that dramatic, but some of the things are. So we want to be very careful and very thoughtful. We're providing it to the political people, the commissioners, so they can help make decisions on zoning or roads or how things are going to go down in the county. All right, this is the quiz portion. What is GIS in general?
This is where you answer the question.
Yes, sir, in the back.
Geographic information system.
That's right. And in general, it's any system that analyzes. Right, and puts it, prepares it for the class. Now, geography matters in this case because it's unlikely I'm going to get this all the way back to you, but thank you for listening. All right, what are the two types of data, hands only, that we use for GIS? Remember? Yes, ma'am?
Raster and vector.
Raster and vector. And raster was what kind of data?
Pixels and pictures.
Pixels and pictures. And vectors are your lines, polygons, and points. Okay, really. All right, and what are the 5 components of a GIS?
Hardware, software, data, methods, and people.
And what's the most important?
Data.
Good data is very important. They all are important, but I think it has to start with good data and good methodology. All right, at this point, I'm actually going to turn it over to Jerry, and then we'll finish up with any questions about GIS, about specific things he's going to say, and wrap it up at the end. So thank you.
Do you need to load? Do you want me to load it?